Well, hello friends, welcome back to browser hacking. Today we're going to continue again with the HTML parser because we're really getting somewhere. So in the first video we fleshed out a basic tokenizer, and then in the second video we fleshed out the basic tree builder or parser. So today we're going to basically just hammer on these things until we can parse our welcome page that we use here as the main test page in the browser. And this is actually going to be a pretty interesting thing to parse because we have all kinds of stuff going on. We have comments, we have inline style sheets, we have a script that gets loaded, and we have a DOM with some links. So a couple of different things here to deal with, and I think it'll be a good task if we can make that work and hook it up in the browser, and then we could maybe add the ability to choose when you start up the browser, like do you want to use the old like legacy parser or the new spec compliant parser. So yeah, that's what we're going to do today, make that work. So but first though, I want to do a couple of little refactorings because some things have been bothering me since yesterday's video. So the first thing is that the lazy mode that I added, where we lazily accumulate characters and try to emit fewer tokens, let's just not do that, because if we do that, then we're going to be out of sync with the documentation. So for now, we're just going to do this, like instead of only creating a new character token once and then putting all the characters into that one, we are just going to do this instead. So when we are in the data state and we get a character coming in, we will append it, and then we will emit that character. So we'll return that's what we do, right? Just to emit that. Return mCurrent token, yeah. And then we can just get rid of the flush mechanism. So because it's just I was getting ahead of myself and trying to like optimize character buffering before we are even like 5% into the implementation. So I think that was a mistake, and let's not do that. We shouldn't optimize before we even understand how this is going to work. Actually, let me verify that it still runs also. I think that shouldn't matter at all. Oh yeah, now it fails because now we're actually emitting character tokens and we don't know how to parse those, but that's okay. Because we never actually dealt with that yesterday. So remove the premature character buffering optimization. Tokenizers. Yeah. Okay, and then let's see, was there something else I wanted to do in the document parser? Yesterday I was talking about putting the element, the active, what was it called, the active element stack? The stack of open elements. I wanted to make a separate class for that. So I think we can put that in its own class. Because then we don't have to say like append and take last and stuff like that. We can say push and pop and whatever else spec language makes sense. So let's just do that real quick. Call it the stack of open elements, maybe. Really drive that point home. maybe that doesn't need a CPP file. So it's a non-null ref putter to vector. Namespace web stack of open elements. Yeah, I think this will be nice. So the way we'll use this is here in the document parser class. Stack of open elements, stack of. So we'll just say stack of open elements, stack of open elements. And then, of course, internally it's still listing. Probably it can be element, actually. And act non-null ref putter vector. And then, let's see, so stack of open elements has element with tag name and scope, so I think we can move this down here. Make a const. Has element with tag name and scope. So we can put that here, or actually maybe we should have a CPP file for this. Maybe that was a better idea. Parser, stack of open elements. Stack of. Oops, what am I even doing? Stack of open elements. Tab name. Alright, so we are just fixing this up right. Nice. I guess this kind of vector can be static, actually. It's not so bad. And then we will need libweb dom elemente. Okay, so then now when we use the stack of open elements here, instead of saying take last, we can say pop. Of course, we have to actually add pop to it. So pop. Stack of open elements, take last. Maybe this should return the element, actually. Maybe we should also rename it to melements, because why not? And we can have a push. Push, oh no, append move element. Maybe we can also have ourselves a little is empty helper. Is empty, all right. That's pretty good. And then, yeah, this is how you use it. And then here, this thing goes away. So stack of open elements has element with tag name and scope. Here you would just say like dot, like that. Maybe this is kind of verbose. Maybe we can like say, or I was thinking we could call this just has in scope, because I feel like the rest of it is pretty understandable. So let's call it has in scope. Okay, and then we have some red, so we'll just pop and pop and pop. Push and oh, current node. Wait, hold on. What are we going to do with current node? I guess we can have a Let's do it this way. Elements last. Yeah, I think this will be okay. Starting to get a little bit better feel for this whole thing now. So here we are. We'll call that current node. And I think it's okay for this thing to return an element. I think. But I may be wrong about this. We'll see. Maybe it's called node for a reason. Maybe let's I mean, it's always the stack of open elements, so it's going to be an element every time. Okay, let's do that. And then you use it like this. Okay. I think that's our refactor. We just need some missing header file here. I guess it's the destructor. We can move that out of line actually. Stack of open elements. This is called has in scope. Invalid use of incomplete type element. Okay. So I guess when you're appending or popping, when you're pushing or popping, then you need to see the element class. Otherwise, we can't do refputter stuff. And then on line 21, we are missing a namespace close. Okay, so I think that's good. We're just gonna go with this right here. All right, so lab factor out the stack of open elements into its own class. Parsers. No. This will allow us to write more expressive parsing code, which is really important, as I keep saying. It's really important to be expressive. So let's bring up the parsing spec again. So yeah, now that we have gotten those little refactorings out of the way that I wanted to do, we're just gonna throw this test page at it and then run until we can do it. Although I guess we can't even do our simplified test for anymore because of the now we actually emit the character nodes or character tokens. So let's deal with that first. So we have the insertion mode is before HTML, and we are getting a new line character. So handle before HTML. Let's see, 130% seems to be a good font size for videos. So what is it that we're doing here? The before HTML insertion mode. So what we have is a character. So it's a character token that is one of the white space characters. Although interestingly, here carriage return is one of them. But in the tokenizing, when you're tokenizing, it does not include carriage return. That's pretty weird. So that's probably for some reason, but we gotta remember to handle that properly. So let's see, a character token. Let me put this on top here. character token, that is one of those. So maybe we can say if token is character and token is parser whitespace. We can differentiate between like tokenizer whitespace and parser whitespace maybe. And then we'll have a helper here. So is parser whitespace. So if it's not character, return false. And then if, or we should assert actually that, or we should have a way to get a code point from this one as well. So code point. Here, I think we can assert that it's character. So let's add a few token helpers here. I think we'll assert that the what's this thing called? Ah, dang it, I forget. Maybe I can't see the definition. Comment or character dot data. Let's just assert that the length is 1. And then we will return m comment or character data view string view. Okay. So this needs some fixing. Fix me. Handle non-ASCII code points properly. But we're not going to deal with that right now. Okay. And then if parser whitespace, that would be switch code point. And then we have the tab character and the line feed, form feed, carriage return, and space. Return true. Default return false. All right, that's our is parser whitespace function. Maybe we'll put a little comment here. Note: the parser considers \r to be whitespace, while the tokenizer does not. Yeah, that's an important little note to be aware of. Okay, so if we encounter this token, then we should ignore it. So that's simple enough. Return. And then let's do the highly scientific method of restart the thing, rebuild, restart, and try again. See what we break on next time. Because this thing is so spider webby that it's like it's easier just to see where we fail next time. So now we're in before head. Character token, another new line, so before head. Character token that is, again, parser whitespace, so that's easy. We can just bring this with us. And do the same thing here. And now we are in before head. We're getting a start tag, and then we are asserting something. An insert HTML element. Okay. That's not what I was expecting. So insert HTML element. Oh, crap, I'm moving. That's my bad. That's when I was doing the stack of open elements. Then I added a move here. But we need the element on the next line. Jeepers. So we shouldn't have done that. Let's see if we can add that in a separate commit. Not quite. All right, let's do a little bit of finessing here, just so we can get that into the previous commit. No, yes. hashed. Yeah, and we want this to go into the previous one. So amend and boom. All right. So back on track. So then that should allow us to proceed. Okay, now we are in afterhead, and we get yet another new line text token. So afterhead, a character token that is parser whitespace. Now we have to insert the character. Finally, some action. All right. So handle afterhead, right? So it's a character token. If token is parser whitespace, then insert character token. And then we got to figure out what that means. So click. When the steps below require the user agent, that's us, to insert a character while processing a token, the user agent must run the following steps. So data is the characters passed to the algorithm, or if no characters were explicitly specified, blah, 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 the character of the character token being processed. So in our case, that's the token. Let the adjusted insertion location be the appropriate place for inserting a node. So let's see. I guess this would look something like this. Insertion, insert the character. And then we're getting our character from a token right now. Maybe we'll need to extend this in the future to accept arbitrary characters, but right now this is fine. So, or we could also, actually we could do it this way, code point, or they call it data, so we'll call it data. And then let the adjusted insertion location is the find appropriate place for inserting a node. Click-clack. We already have that. And then if the adjusted insertion location is a document, if it's in a document. Right, so the document node cannot have text children. That's what it says here. Yeah, the DOM doesn't let you put text children into the document. Like the very root of the DOM can't have text children. So we just do nothing if that happens. So if the insertion location is a document, return. Okay, and then if there is a text node immediately before the adjusted insertion location, then append data to that text node's data. Otherwise, create a new text node whose data is data and whose node document is the same as that of the element in which the adjusted insertion location finds itself. And then insert the text node at the insertion location. So basically, let's see, let me just add this to the class declaration so that things highlight correctly. So, if the last child of the insertion location exists and last child is a text node, then we should append to that text node. Append to existing text node, return. Otherwise, we should create a new text node with this character in it. So we can do something like this, builder append let's be good boys and use UTF-32 view. Just because. Oh, I need to include it. All right, so we're not going for a fast parser at first. We're not going to do any optimizations. We're going to build it correctly so that it parses the web correctly, and then we can start worrying about going fast later. Like right now, it doesn't matter at all. So we will just say adjusted insertion location, append child, create a new text node in document with the builder to string as its text content. And then we'll need to include libweb.text. Let me collapse this. Okay, so new text. Right, and if we have an existing text node, then what we should do here is append it to that one. So in that case, it's more like we make a builder and then we put whatever the text is already. So to text last child dot data. So we take the existing text and then we append one teensy tiny code point, and then I guess we just set the, let me put this in a text node. We'll call it the existing text node. There we go. Now we need a way to set the data. So it's a little bit of a weird thing. I think normally you can't, or can you set the data of a text node? I'm not even sure. Regardless, let's just have a way of doing that. So here we can say toString. This is obviously not very fast, like allocating a new string every time that we add a single character to a text node, but it'll be okay. So this will go in character data, put here set data. Something like that. So this should now allow us to insert character. I forgot to put a close paren somewhere here. Okay, now we are in body, handle in body. And what is the condition? In body. So this would be, it was another new line, right? Yeah, just a new line character. So it's a character token that is one of the parser whitespace characters. Then we should do this: reconstruct the active formatting elements, if any, and then insert the token's character. So let's just put this first. If token is character, then I guess we can put this first here. So if token code point is null, we'll assert not reached, because we don't have a way to express parse error yet. Okay, and then if character token is parser whitespace, then reconstruct active formatting elements. Reconstruct the active formatting elements. I don't know what that means, but I guess we'll find out. And then insert character token code point. Return. So let's follow the rabbit. That is a modest 10 steps that we have to do, okay. When the steps below require the user agent to reconstruct the active formatting elements, the UA must perform the following steps. If there are no entries in the list of active formatting elements, then there is nothing to reconstruct. Stop this algorithm. Maybe we're lucky and there's nothing in there. Initially, the list of active formatting elements is empty. It is used to handle misnested formatting element tags. Okay, and formatting elements are the following HTML elements are those that end up in the list of active formatting elements. It's A, B, big, code, M, font, I, knobber, S, small, strike, strong, teta, and U. Cool. So basically it's a set of tags, and when we encounter them, then they go into a list of active formatting elements somehow, presumably when you open one, it goes on that list, and then because web content is highly prone to close those things, let's say out of order quite often. So I guess there's some algorithm here that deals with that. So we should probably have a list of these. So I don't know if it's going to be its own class, but we can put them in a non-null ref.vector vector to element list of active formatting elements. We'll have that. Okay. And markers. So wait, it has elements in that category and markers. So I guess it doesn't only have elements, but also markers, and the markers are they're not elements, they're something else. Or I'm not sure exactly, but we'll work it out as we go. So reconstruct the active formatting elements. Let's make that a function that we can call. And then we'll let you call it, and then here we were supposed to do something. Where did our thing go? Here, reconstruct the active format elements. So if there are no entries in the list, so maybe we can get away with just saying if list of that thing is empty, stop the algorithm, right? So this has to be implemented, but maybe we don't have to do it right now. So let's go back to in-body. And yeah, so then we'll insert that token. Let's see if we can make progress here. Okay, now we're in after body. And we have yet another white space. After body. And we should, this is interesting though, we should process the token using the rules for the in-body insertion mode. So what does that mean? Did we switch modes, or? Several of these modes are special in that the other modes defer to them at various times. When the algorithm below says that the user agent is to do something using the rules for the insertion mode, where is one of these modes, the user agent must use the rules described under that insertion mode section, but must leave the insertion mode unchanged, unless the rules in themselves switch the insertion mode to a new value. Right, so we just want to sort of use a different one, so we want to handle it as if we're in body, but we don't want to update the insertion mode. So if token is character and token is parser wide space, then we could just say like handle in body token. but I don't love the way that reads. What if we would say process using the rules for insertion mode in body? That has a nicer ring to it to me. And then we also need to pass the token, I guess. So let's see. Maybe this can just be the way that we always invoke the handle function. So let's see, let's put that here and then that there. And process using the rules for can just be our little dispatch switch statement here. So HTML doc parser insertion mode. And then we will take this guy right here and snippety snap him, put him down here. And then in the main run loop, we just say process using the rules for M insertion mode. And then here we look at mode. Oh, and token. So I think that's kind of neat. Because then we can defer to an alternate mode in an expressive way, because now we can literally say process the token using the rules for another insertion mode. That's good. So now we are in after body, which I think will be our final state, possibly. We'll see. At least for this document. So when we're going to apply these rules, what was our token? We have a new line token. So it's either a doc type or a whitespace character or a start tag HTML. So if token is doc type or token is parse whitespace or token is start tag and token tag name is HTML. Then what we should do is process using the rules for the in-body insertion mode. Cool. So let's see if we get to the end here. We got to the end. Look at that. And this is our DOM. And now the DOM actually has all of these, meaningless whitespace text nodes in it. So let's see. Sample. Yeah. So that's our thing. It's interesting that there's more white space in this one. I feel like there should be less, but... Or actually, wait, no. I was thinking that the white space here was inside of the div, but it's actually after the div. Div has nothing in it, right? Because they're on the same indentation level. So the white space after here is the white space after the div, and then there's white space after the body. White space is such a weird thing in HTML. But you have, like, the fact that you have to actually track and render all this white space, even though it's pretty clear from looking at the HTML that I don't care about that white space. But we still have to care about it for a correct rendering, so. But that's great. That means that we're up to speed, so let's say liblab. Implement enough of the implement more start implementing character token parsing. Now that we've gotten rid of the misguided character buffering in the tokenizer. It actually spits out character tokens that we have to deal with the parser. This patch implements enough to bring us back to speed with simple HTML. Okay. Now, let's start futzing with that welcome test page. So I'm going to make that the default page here. And then we'll just run it and see what breaks. Okay, so we are in head and we're getting a new line. So in head, insertion mode. Okay, so we should just, if it's a character token that's new line, we should just insert it. That's easy enough. So if token is, I guess we can just say is parser white space, insert character token. Straightforward. Oh, we have to say token code. Alright, then we are in head and we get a start tag with name title. Cool. Start tag whose name is title. Follow the generic RC data element parsing algorithm. Okay, well, I don't know what that is, but I guess we'll do it. So the generic raw text element parsing algo and RC data element parsing algo consists of the following steps. Insert an HTML element for the token. If the algorithm that was invoked is the generic raw text element, that's not the one. This is the one that we have, the RC data. So we should switch the tokenizer to the RC data state. Interesting. So now we actually get to a point where the parser starts changing the state of the tokenizer a little bit. Just a little bit. So that's very interesting. And then let the original insertion mode be the current insertion mode, and then switch to text. So when we switch to text or in table text, then the original insertion mode is also set. So basically that's an insertion mode that we can return to. I guess once we finish this RC data business. So let's see. What was the spec language here? Follow the generic RC data element parsing algorithm. So does that happen in more places, I wonder? That's only in one place? Okay, so since this is only done in one place, let's see. Oh, wait, what does my phone want? Nothing I have to deal with right now. So anyway, I think we don't need to have a function called follow the generic RC data element parsing algorithm if it's only called from one place. So we can do it here instead. But we have to check if it's a start tag whose name is title. So if token is start tag and token tag name. Okay. Then what we should do is insert an HTML element for this token. And then we should switch the tokenizer to RC data. So tokenizer, can we switch to I guess we can just like be hardcore and write to it. No, we can't. Okay. Set state. Switch. Let's call it switch from parser maybe. Or how do we say that we're switching it? Switch to. We pass a badge. That's how we'll know. HTML tokenizer state RC data. Original insertion mode is the current insertion mode, and then M insertion mode becomes text. Return. Okay, so let's have a place to store this. So this can be initial, I guess. It probably doesn't really matter, but it's just our little backup insertion mode that we can fall back to somehow later. And then I was thinking, should we just make the tokenizer friendly with the document parser? But we've been such good boys having this clean API, so maybe we can keep it that way. Maybe we don't need a badge, actually. Switch to state. Or, you know what, let's put a badge here. Just for documentation purposes, if nothing else. Use of undeclared identifier. Okay, so we should probably put the state enum earlier. And maybe this is not in the web forwarding thingy. Okay. And then here we'll say tokenizer switch to M state is new state. And then if we are gonna have some debug logging for this, so if we are tracing switching tokenizer state from parser or to parser switches. Yeah, I just want to see what it looks like. Okay, so the parser switches the tokenizer state to RC data. That's pretty cool. And then we crash in the tokenizer. 725. Wait, no, where did we crash? 725. So here, because we have an unimplemented tokenizer state, so we get to do some tokenizing again. It's an RC data, yeah. So let's see how that works. Okay, now we have to implement some of this. So let's see if we can remember how to do that. On ampersand. Return state is state RC data. Switch to character reference. Okay. Switch to RC data less than sign. And on null character, this to-do macro, I like it. We should probably bring that to more places. I don't know. I added a to-do macro, and what it does, it just, it's like assert not reached, but it prints out a little thing first, and just to tell us that, hey, there's something to do here. I find that it's a little bit more expressive than saying assert not reached, right? For because in the Serenity code base, we've really been conflating assert not reached, and this part here is not implemented yet. Because assert not reached is really supposed to be, this thing here should not be reached during normal healthy execution, but we're mixing that up a little bit with, oh, I need to implement this. So that's not very good. End state here. So anyway, that's just something I'm thinking about more and more. Anything else? Emit the current input character as a character token. So that's what we were doing up here. We should probably emit current character. We should probably just have a healthy macro for that. Okay, and then RC data. Let's go back down. Emit current character, right? So we're in the title tag, and then we're gonna read some title text, and then eventually we'll get a less than sign, right? So then we gotta jump to, because that will be like the title close tag coming up. So we need to implement that state, which will be the RC data less than sign. So we'll follow the rabbit. And it says on slash, aka solidus, set the temporary buffer to the empty string. What's a temporary buffer, you wonder? I also wonder that. Maybe we'll make that a string builder that we stash on the tokenizer. I'm not exactly sure what this is for, but I have a feeling that we can use a string builder probably. String builder temporary buffer. Okay, and then switch to RC data and tag open. Anything else? Emit, oh wait, we want to emit a specific character and then reconsume in the RC data state. So we'll have emit character and then reconsume in RC data. Okay, and then emit the current character code point, and here we'll just put the code point, and then this here becomes a bit easier because we just say current input character value. Cool. So let's see where this takes us. Now comes the end tag open state. RC data and tag open, in which we will check on ASCII alpha. Create a new end tag token. So current token is, wait, do we have some thing for that, right? I already forgot how the tokenizer works. It's like 2 days ago since I worked on it. Type end tag, okay. And set its name to the empty string, and then reconsume in RC data end tag name state. Anything else? Emit character less than sign. And a solidus character token. So, oh wait, shit. We want to emit 2 characters? how do we do that? That's tricky. We want to hand 2 tokens to the parser. We don't have a way to communicate 2 tokens to the parser at this point, so I'm going to say assert not reached here, or to do. So I'll say this. Fix me. That'll be a bit weird. But we'll work something out. We just don't have to deal with it right now because it's sort of error recovery, right? So begin state, RC data, end tag name. Okay, and then what do we do in this state? We check on white space. If the current end tag token is an appropriate end tag token. Wait, have we been doing this already? End tag. We don't have some idiom for that. But we do have end tag name, don't we? Tag name. End tag open tag name. If the current end tag token is an appropriate end tag token, then switch to the before attribute namestate. Are we even gonna be here? Wait, what? What does it say here in our title? Welcome exclamation point, right? So we're here, and then we're here, end tag name, so we're reading regular characters. I think we'll just do we'll just put a to do here. Because there are so many things that we gotta figure out in the glorious future where we actually figure out how to do all these things. So for now, let's just do this. And then on ASCII upper alpha, append the lowercase version of the current input character to the current tag token's tag name. M tag name, append to lower current input character value. Cool. To the current tag token's tag name, and append it to the temporary buffer, not lowercase. Okay, so we append the unadulterated character, not lowered, to the temporary buffer, and then we carry on. On ASCII lower alpha, which we should, I guess, implement. So on ASCII lower alpha, so if it's between A and Z, then presumably we do the same thing, except we don't lowercase it. Yeah, so it's the same thing. And you could write these things. You could like mash these together and so on. But I feel like it's better that we just stick to doing it the way the spec does it. Anything else to do? Okay. let's actually see how far we get. See if we can get some error message out of it. Took out title. Then we're in text insertion mode, and we're getting a W. So I guess we haven't actually implemented the text insertion mode. Do we have handle text? Okay. So what are we going to do with that? Text insertion mode. We got a character, so we insert the tokens character. Easy enough. And we'll see what comes next. Okay, so we are inserting welcome. That's nice. And then we have RC data end tag name and the end tag, universal end tag symbol greater than. Let's see, data end tag name. So we're here. This guy showed up. So what are we supposed to do? If the current end tag token is an appropriate end tag token, then switch to the data state and emit the current tag token. So what does that mean? If the end tag token whose tag name matches the tag name of the last start tag to have been emitted from this tokenizer, if any. If no start tag has been emitted, then no end tag token is appropriate. So basically, we just need to remember what was the last start tag we emitted. Cool. Well, we can do that. So it's not so bad. End tag name. Where were we? Here. If the current token end tag if current end tag token is appropriate, I guess if it's not appropriate, then we should go to anything else. Or wait, can we go to? We can't really go to here because we are in a big switch statement. So we should treat it as per the anything else entry below. So, you know what? If it's not appropriate to do, we'll deal with that then. Fix me. All right. But if it is appropriate, that means that we should switch to the data state and emit the current tag token. So emit, switch to, and emit current token. Switch to data. Right. So now we just have to create this helper function in the tokenizer. Cool. Current end tag token is appropriate. And then I think how do we know that if it's appropriate? The last start tag to have been emitted. So when we emit a start tag, we have to just stash it somewhere. So we can do it this way: HTML token last emitted start tag, and then say will emit can do this everywhere. So that we have a chance to inspect it before we go. Will emit then we'll say if token is start tag, then m last emitted start tag is token. That'll be downright nifty. All right, and then we have to implement current end tag token is appropriate. Totally forgot about that. And that checks if whose tag name matches the right, so we'll assert that the current token is an end tag, and then we will check current token tag name is the same as the last emitted start tag name. And if m last emitted start tag type is not, or wait, if it's not a start tag, so we didn't emit the start tag yet, then that's not appropriate, dude. So that would be our, wait, we don't have an invalid state? Oh, we should have an invalid state for this guy. Otherwise this can be a bit weird. Well, so I guess we just have to do something for invalid. We'll just say case HTML token type invalid, and then we assert that you don't try to do anything with that, because in this case it is intentionally a assert not reached, because you should never try to stringify an invalid token. Okay, we're still in RC data end tag name, RC datum, and tag name. Wait, so is the end tag not appropriate? Assertion false on 806. So we're here. The current end tag is not appropriate. Why is that so? Wait, are we returning the token somewhere manually instead of using an emit macro? Am I failing to call will emit somewhere? Yes, right here. Will emit. Okay, so we're in text, we got an end tag, and now we have to deal with that. Handle text. So text insertion mode. Isn't it fun to implement HTML parsing, you guys? I feel like this is, it's like I'm coloring by numbers or something, but it's really chill, and we're clearly like making slow incremental progress here, so it's gonna be awesome having a really good proper HTML parser in the Serenity browser, and this is really the only way to build one. So at least that I can think of. So we had an end tag whose name was title, which would be any other end tag. It is end tag. And then there was a special case up there for end tag and token tag name is script, because we gotta deal with that scenario, but we don't have to do that right now. Oh, we don't have to do here. Maybe we should port over to do from the tokenizer, because now it's irritating not to have it. Wait, how do we get the state name? Can we get the state name? Insertion mode. Okay, well, for now, let's just say I'm just going to cast it to an int. And, or, you know what? This is fine. I just want to be able to say to do. End tag, name, title, crashing on 414. Okay, so what we should do here is pop the current node off the stack of open elements. Stack of open elements pop. Then switch the insertion mode to the original insertion mode, and then return. Let's see what happens. Okay. So now we are in head, and we get a comment with this in it. This is a comment. Wait, space, home, and on the welcome. This comment right here, but I feel like the apostrophe is a little bit weird here. Why is there no end apostrophe? Oh, we don't put one? We should put one. Oh, like all of these are like that. I didn't even realize that we only had the first apostrophe. Okay, so what are we in? We're in head and we got a comment. Okay, so we got a comment token, so we should insert a comment. Sounds easy enough, right? Head. So it's right after the white space scenario. So if token is comment, or you know what, maybe we should commit here, just since we've made some progress. The web. It's like, what do we even say in this kind of commit? We're just like pushing forward. More work on the HTML parser and tokenizer. The parser can now switch the state of the tokenizer, which is very webby. Okay, so then we'll do the comment. Because like when you're doing this kind of like spec-driven implementation work, it's like should you sit there and like write out commit messages about what you're doing every step of the way? You can. I think it's the important part is to have like checkpoints that you're committing regularly so that you can sort of bisect between things if something goes wrong, but and just because it's good to have like like if I do git diff, then it's good to be able to get an overview of what I'm actually doing, right? But I think it's not super crucial to write out just long commit messages every step of the way. So if it's comment, then insert comment. Guess from token, and we need to figure out what that does. So what does that do? Insert a comment. Let data be the data given the comment token being processed. If position was specified, which it was not, then let the adjusted insertion location be that. Otherwise, look it up like we normally do. Okay, so HTML document parser, insert comment. Then here we'll just say data is token, comment or character data to string, and then adjusted insertion location is find appropriate place for inserting node create a comment node whose data attribute is set to data. Well, comment is, oh, do we have comment nodes? I guess we do. Comment, yeah, we do. New comment in document with the data. And then we insert it at the adjusted insertion location, which means that we append child. So in fact, this can just be mashed together like that. That's pretty cool. So let's see. Put that next to insert character because I feel like they're kind of spirit buddies. Okay. Let's see if we can insert this comment. All right, cool. So now we're trying to start, we're in head and we're doing a style tag. Maybe we can commit right here. So libweb port inserting that's in head. Support comments in head insertion mode. See, I was just saying that we don't need to write those kind of commit messages, and I'm just doing one anyway. Nothing wrong with that. Nothing wrong either way, I think. So what did I want to do? I had a style tag in the in head. So that's one of these. Coming after title here, so if token is start tag and tag token tag name is no script. If the scripting flag is enabled, what's that? If scripting was enabled, okay, so let's see if it's no script and M scripting enabled. We'll have a flag for that. So, or if star tag is no frames for style. So either this state or token tag name. No frames. Was it no frames or style? Yeah. Okay, then we just need to add that Boolean thing, scripting enabled. We'll just say always true. Because you know, in the future we might want to have the ability to turn off scripting, but right now we don't care. And then we should follow the generic raw text element parsing algo. That one is invoked in more places, so so should we just say generic raw text element, parse generic raw text element, something like that. Is that what they call it? Follow the generic. Yeah, okay, so we'll say that. But this is the same as the RC data thingy, right? So it's just that we switch to raw text rather than switching to RC data. And then I bet you that we have to do some copy paste work in the tokenizer. But essentially this thing here is going to be just the same. So it's this, except we switch to raw text. Yes, sir. And of course the hatch to mul token. Token. Okay, so now we'll switch to raw text, which of course the tokenizer is not going to be knowing what to do, but we can deal with that in a moment. So tokenizer crashing on 831. And 831 tokenizer. Right, so we need raw text, but I bet you that raw text and RC data are very similar. So I'm willing to bet that a copy-paste job here might not be a bad idea, although now we have to be real careful to validate that this is true. So RC data would be raw text, and immediately there's no ampersand handling, but here we switch to raw text less than sign. This one can be a to do, emit the off, and that part is good. Okay. Raw text less than sign. Solidus, switch to raw text and tag open. Okay. And reconsume in raw text. Okay, on ASCII alpha, create new end tag token, set its tag name to the empty string, reconsume it in raw text. Anything else, do this problem again, except reconsume in raw text state. Okay, that was the raw text end tag open, and then finally we are in raw text end tag name. So on white space to do, on slash to do, on greater than sign, if it's appropriate, then switch to the data state and emit the current tag token. Right. Switch to data state, blah, blah, blah. ASCII upper and lower. Append to the current tag token's tag name, and append the unadulterated input character to the temporary buffer. And then for anything else, we do some thing. Oh, here, that's what the temporary buffer is for. So if you hit anything else here, we're supposed to take all of the characters in the temporary buffer and emit them in the order they were added. So I'm not sure how we're going to achieve that, but that's something we don't have to solve right now. But I think that was enough to get the raw text states. So let's see if we can handle that. Seems like we did. So now we are in head, and we're getting a new start tag, which is a script. So this was our style tag that we handled, I guess. Yeah. Web, parse enough, handle a style inside a head. Okay. So now we are in head, and we're getting a script. So here we are. Parser. is script. And then, what's going on here? Run these steps. Let the adjusted insertion location, all right, say no more. Create an element for the token. You got it? Set the element's parser document and unset its non-blocking flag. I don't know what either of those things are. The script element has a parser document, which is either null or a document. Initially, its value must be null. It's set by the parser and affects the processing of those elements. Script elements with non-null parser documents are known as parser inserted. Interesting. And we should unset the script element's non-blocking flag. All right, so I guess we need to do that. So here, this one will return an element. So let's say script element is to HTML script element. Then we will need to reach into that. And then we'll say script element set parser document, our document. We'll say that pass a badge so that he knows that we're the parser. Script element, unset the non-blocking flag. Okay, so set non-blocking false, I guess. So I don't know what the lifetime of this linkage is going to be. So in the case of the parser document, I don't know if I want that to be a reference counting pointer or if it's going to be cleared later. The parser document. I guess we'll remember the parser document. But it's okay, let's not overthink this. Let's just say we put her to document. And if for some reason the document goes away, then, you know, whatever. We'll think about that later. This will be a badge to document parser. Something like this. And we'll have bool m non-blocking. I kind of wish it would have been called blocking, but you know, it's okay. So let's put these guys out of line. And script element, non-blocking, and non-blocking is non-blocking. I'm guessing we were going to want to look at this at some point, so I'll just expose it. Okay, there we go, and this ensures that if the script is external, any document.write calls in the script will execute in line, instead of blowing the document away, as would happen in most other cases. See, this guy knows how browsers work. That's certainly what would happen in many situations. It also prevents the script from executing until the end tag is seen. All right. And then if we're doing fragment parsing, so let's see, if m parsing fragment to do. And then if we were invoked, we had document write or document write line. Interesting. So we should probably have that as let's see, if m invoked via document write to do. Let's have a flag for that, which will be false because we don't have document write, and then someday we can implement that and then we'll set that flag. Okay, and then insert the element. So adjusted insertion location, append child element. Push it on the stack of open elements. Switch to Tokenizer to the Tokenizer state script data, and let the original insertion mode be the current insertion mode. Return. Oh wait, hold on. No, we should switch to text. Insertion mode text. This is pleasant, isn't it? I'm having fun. I don't know if this is interesting to watch. I hope it is. I find it really, really pleasant work. And it's like, it's very, very straightforward. Just implementing a spec. All right, so what are we messing up here? We're failing an ist. So that's probably my conversion here. I tried to create an element, but he says he's not a script element. Oh, because we haven't, we need to implement is for this guy. So the is function relies on the presence of an is helper. And currently the way they work is that it just takes a node and then checks the tag name. So it's not very scientific, but it is what it is. And now we will correctly detect a script element. Okay, so now we are failing incomplete URL. Okay, script element inserted into write. So we have to turn off these callbacks somehow, because this is like the old parser works in a certain way when it comes to inserting a script element and then executing the script inside of it, and the new parser hasn't put the text into the thing yet, so it's not going to work. And then also, what other problem are we having? We're calling complete URL with an attribute, and the attribute is presumably empty, although we check that here. Why are we seeing a null putter deref, I wonder? Complete URL. What is going on here? Well, I don't know exactly what's going wrong here, but we don't want to go into this function anyway. Okay, so how is it that we invoke this thing right now? It's done by the tree node append child. And we always do this right. So whenever we append a child to something else, then we always called inserted into on the child. And in this case, we want to kind of stop doing that. Alternatively, we could also, or no, we really just want to stop doing it in this case. So we used to have a parameter for this called inserted into. Let's just put this back, and then we can default to true, and then when we use it in the parser, we can say don't call inserted into. So if call inserted into and then in the HTML doc parser here, where we actually insert the elements, we call append child, we'll just say false. So there's a little bit of a hack because we'll be able to get rid of this once we get rid of the old parser, but for now I think we'll have to have separate behaviors while we are transitioning to a new parser. Because I don't want to go and work on the old parser and make it handle script insertion in a different way, because that would just be wasted work. So, HTML tokenizer 919. Then we're here. We're in some state that we can't handle. I guess we should say to do here, actually, because it means that we are missing some state. Let's see which one it is. Although I have a feeling it's going to be script data. Look at that. To do script data. And then we have one of these guys. Wait, does that make sense? We switch to script data state, and then the very first thing is one of these guys. I mean, maybe that makes sense. I don't know. We'll see. We'll just start implementing this. In state. Script data. So what do we do in script data? On less than sign. Switch to the script data less than sign state. Cool. On null, that's a parse error. On eoff, that's emit eoff. Anything else? Emit the current character. Cool. And state. And then we jump to script data less than sign. Okay, and here we have the famous solidus. So we'll get the temporary buffer becomes the empty string. So temporary buffer clear, switch to the script data and tag open. On exclamation point, switch to script data escape start. I guess this is, yeah, we're gonna have to deal with that. So many times, especially in older content, you see stuff like this. And they, I mean, not this, but like they do the JavaScript stuff here, right? And this was like a way that people did in the old times to hide scripts from browsers that couldn't handle it. And then because those scripts hung around forever, then we're stuck with them forever. It's nice. So script data less than sign state. That's almost finished. Anything else? Emit character less than sign, reconsume in script data. Okay, then we can go to the script data end tag open state. Cool. On ASCII alpha, create new token, HTML token type, end tag. We consume in script data and tag name. Anything else? We'll say to do because again it wants us to emit more than one character, which we can't do at the moment. So we'll do the next state instead. So this will be the script data and tag name state. On white space, I think maybe we'll the escape exclamation point escape thing we'll do as to do for now. On white space, if current end tag token is appropriate, then switch to before attribute thing. Otherwise, to do, so let's say fix me. Okay, and then we have I guess we can do a solidus thingy. So if the current end tag token is appropriate, switch to self-closing start tag state. Otherwise, same story here. On greater than sign, if current end tag token is appropriate, switch to and emit current token data. Otherwise, same. Alright, and then we have ASCII upper and ASCII lower alpha. Let's see, do we have those here somewhere? Lowercase thingy. Not want to append to the doc type. We want to append to the current tag token. Tag name, append to lower, and then we also append to the temporary buffer. All right, and then on ASCII lower alpha, basically the same story, except we don't have the to lower. Anything else? And there's a multiple emit, so we'll say to do. And is this enough to get us through? Did we forget something? Error, macro expands to multiple statements. I guess in this case I need to do this. Yeah, it's the classic macro problem that we did here. Actually, let's improve the macro because we have multiple statements, and then when you expand it, because it's an if, so then we would only do this in response to the condition being true, and then these would go under the if, which is not what we want. So the typical thing that you would do is something like this. Which allows you to do this under an if. It also forces a semicolon, which can be nice. I mean, it forces you to put a semicolon when using this. since there's a missing semicolon here. Let's just do this for all of them. Wow. Okay, we're almost there. Okay, I think that's good. So, now we can actually do that. Script data end tag name, and we got an S. Okay. Script data end tag name. Did we do anything with that state? Script data end tag name. Oh, wait, we need to continue here. We can't just fall through. That's not what we want. I guess falling through would be one way of getting to the anything else branch, but it would be very, very hard to follow. Okay, so we open the script and then we end tag the script in text. Text insertion mode, and we got this is an end tag whose name is script. Handle text. So what is this? Handle end tag. Oh, this is any under. Oh, we're here. Right. Yeah. So, okay. So this is actually kind of got a lot of stuff going on here. So, the JavaScript execution context stack. Okay, so this is about microtasks and stuff, and I guess promise things, but we don't have. We haven't really built this model in the libjs engine yet, so we'll just skip over this part. So let's say that script is the current node to HTML script element current node. All right. Then pop the current node off of the stack of open elements. Well, I'm not gonna play it fast and loose here, so we'll do a nominal rough footer to HTML script element, just to be sure that we are holding on to a reference to it, like a strong reference. And then we will stack of open elements pop, and then we'll switch the insertion mode. Insertion mode is the original insertion mode. Old insertion point is the current insertion point, okay? What is the insertion point anyway? The position just before a character or just before the end of the input stream where content inserted using document write is actually inserted. The insertion point is relative to the position of the character immediately after it. It is not an absolute offset into the input stream. So this wait. Just before a character or at the end of the input stream where content inserted is actually inserted. So is this the insertion point into the tokenizer stream, I guess? So it's not the insertion point in the it's not the insertion point in the parsing context, like where you would insert something in the tree, but rather it's the insertion point in the tokenizing stream. So this is if we actually want to insert some crap into the stream of tokens, but we're not gonna handle that right now, I think. So let the insertion point be just before the next input character. So fix me handle on tokenizer insertion point stuff here. And then increment the parser's script nesting level by 1. Well, I know how to increment things. Although, what is the script nesting level? To handle these cases. Okay, so it's just, you know what, let's just say increment script nesting level. Do we eventually decrement it? We decrement it at some point later. Okay, so let's see. Let's set size t, or I can use an int, whatever. Or no, let's use a size t. Script nesting level should be 0, and we'll have increment and decrement, and maybe even script nesting level const return m script nesting level. See? Logical. And I think these guys are going to have to script nesting level. So I think when we decrement, we're going to make sure that we don't overflow. So we'll assert that the script nesting level is non-zero. Okay. And then what's going on here? Prepare the script. Okay, that's something that we have to do. What does this mean? Prepare the script. So I guess here we will do script prepare script, I guess. And we can do that inside of the script element. And then after that, we decrement the script nesting level. Okay, so decrement script nesting level. Parser pause flag. Maybe we should have that thing too, even though I'm not sure what it is yet. Pause. Just call it pause flag. Parser pause flag, since that's what they keep calling it. So, if the parser script nesting level is 0, set the parser pause flag to false. We can do that. They say to do it right here. So if script nesting level is 0, set the parser pause flag to false. And then fix me handle tokenizer insertion point stuff here too. So you restore the insertion point to the previous value. Okay. And then if there is a pending parsing blocking script, that must mean that I'm not sure exactly what that means, but we'll work that out later. Let's do the prepare thing now. So let's see what prepare actually entails. Prepare script. Maybe only the parser is going to call this. Maybe we'll see. We'll pass a batch for now. Okay. If we have already started, then return. Already started is what exactly? It's an unset flag. Well, let's add the flag. If m already started, return. Cool. And then let the parser document be the elements parser document. So we are here, we can do this. So parser document is, we already stashed that away here. So I think maybe we'll put this maybe in like a ref footer. I don't really know what kind of shenanigans are about to happen here, so do something like that. And then set the elements parser document to null. Interesting. So this is where we actually clear the parser document. This is done so that if parser inserted script elements fail to run when the parser tries to run them, for example because they're empty or specify an unsupported scripting language, another script can later mutate them and cause them to run again. Okay, well, whatever. So let's not ask too many questions here. So if the parser document is non-null, if parser document and does not have attribute async, then set the non-blocking flag to true. Okay. Then let source text be the element's child text content. So source text is child text content. No, we don't have that. How do we get that? What were we doing up here? Source. Oh, this is what we do. Okay, so here we just child text content. Maybe we should put this in a helper. Child text content of a what exactly? Of a node. Okay, yeah, that should be a thing. So node.h child text content. Cool. We can't call for each child. Wait, why can't we do that? Oh, it only works on parent node. As parent node. Return empty string. Otherwise, we will do parent node ourselves. Yeah, this is a little grungy, but it's okay. So, child source text is child text content. And if the element has no source attribute and source text is the empty string, then return. So if no attribute called source and source text is the empty string, return. If the element is not connected, if its shadow including root is a document, I guess that means that we are in the document. It's roots, hosts, shadow, including root. The root of an object is itself if its parent is null, or else if it is the root of its parent. Right, and then your host is a document fragment node has an associated host. Okay, so this is getting into Shadow DOM stuff, which we don't care about right now. So if the element is not connected, then I guess we can just check if is not connected, return, and then this will be a node feature. So how do we check if a DOM node is connected? I guess is connected. Node is connected. My understanding is that you walk the parent chain and verify that that you are connected to what exactly? Wait, what did it say? It's a document, right? So wait. Oh, why is this so hard to follow? Shadow including root. Return root is okay, and then what is my root? I mean, I guess it's another node, right? While root parent so there we go. If the element is not connected, then return. Fine. If either we have a type. Okay, so this is the type attribute. So we'll just say here, like, fix me, check the type attribute. So we're just going to be lazy here and skip over this part. That'll be a fix me type and language attributes. We'll just assume JavaScript right now. And then we're going to set back the parser document. So we can just set it back if possible. So if parser document, then make a new weak pointer to it. Cool. And set the non-blocking flag to false. Cool. And then we set the elements already started flag true. We set our preparation time document. I don't know if we're actually going to need all these things for anything important, but what is your node document? Oh, okay, it's just our associated document. So that would be our document, make weak pointer. Okay. If parser document is non-null and parser document is not preparation time document. What is a preparation time document? It's a document determined near the beginning of the prepare script algorithm. It's used to prevent scripts that move between documents during preparation from executing. Sneaky. Okay. So if they're not the same document, then we return. This step is not interoperable and is under debate. Ooh, they're arguing about it. Should the parser execute scripts creating in another document? And look, here's, what's his name? Jaffa. Seems like, oh wow, look at that. They started talking about this 2016, and the last comment is 18 hours ago. So that's interesting. Anyways, we'll just do what it says right now and see what happens. If they change it, we can change our minds later. It's one of the joys of working with a living spec like this, that tomorrow it might be different. That's just how it is. So if scripting is disabled for the script element, what does that mean? Okay, so if scripting is disabled for whatever reason, fix me check if scripting is disabled. If so, return. Okay. If the script element has a no module and the script's type is classic, fix me check the no module content attribute. Yes. Okay. Well, and then fix me check source. Oh, wait, hold on. If no attribute src, you know what? Let's just say fix me check CSP. Okay, and then fix me the event and 4 attributes. There's so many goofy attributes here. We're not going to do all of them. We're just going to try to get this page to run. Event and 4 attributes. If it has a char set, fix me check course. Fix me module script credentials mode. Fix me the cryptographic nonce. There are a lot of things here. Check integrity attribute and the refer policy. Okay, and then we have parser metadata. Is either parser inserted or not parser inserted? So I think we'll use a Boolean for that. Let's see. So script elements with a non-null parser documents are known as parser inserted. So basically, parser inserted is whether or not our parser document is non-null. Not sure if this needs to be a separate flag, but we are just we're just rolling with this spec right now. We're at 23 out of how many steps? 28, so we're getting there. 24. Fix me check fetch options. Fix me check. Oh wait, what's the settings object? So I guess this is the, now we're actually going to fetch the frickin' resource here if needed. If has attribute source, finally some action. Source is attribute source, sure. If source is empty, fix me, we'll say assert not reached, and fix me, fire an error event at the element and return. The elements from an external file flag to true. We can set that. All right. Parse src relative to the elements node document. Okay, I know how to do that. URL is document complete URL src. If that failed, so if URL is not valid, fire an error event. Otherwise, let URL be the resulting URL record. So way ahead of you spec for once. Okay, and then we switch on the script type. Fix me, check module, classic VS module type. And here we're just going to fetch a classic script. And that's its own steps. But I think here we can just be a little bit lazy and do what we've already been doing. So we have a snippet here that does a synchronous load. So let's see how that works in practice. src, okay. When the chosen algorithm asynchronously completes, set the script's script to the result. At that time, the script is ready. So we don't have to do this synchronously, actually. We can do this asynchronously, which would be the good boy thing to do. So let's do it async. Then we want to set the script's script to the result. So the script for a script element is either null or a script. It's one of two possible structs. All right. So a whole bunch of things here. So a script, we should probably come up with a script object, but we don't need to do that right now. We can just say script source. Script source. Yeah. That's what we'll do. And since this is async, we'll just capture this. And source is whatever the URL is, I guess. And this will be a big beefy string. Okay, so we're taking a little bit of liberties here, but nothing too crazy. And when the chosen algos asynchronously completes, set the script to the result. That's what we're doing here. At that time, the script is ready. So the script is ready. For performance reasons, you may start fetching scripts as soon as the attribute is set, hoping that it will be inserted into the document, right? So you can speculatively load scripts before, like as soon as you see the source attribute in the, even like very early in the parser, maybe even in the tokenizer if you wanted to, you could fire off a load. I think that's probably what browsers do. So blah blah blah. Once the element is inserted into the document, the load must have started. If the element does not have a source content attribute, so this is like the else here. So if it's an inline script, then script will be the result of creating classic script using source text. So script source is the source text, right? It's our concatenated text children. And then the script is ready. And script ready is true. Okay, so m script ready false. Okay. Fix me, check classic BS module script type. And then defer, wait. If we have defer and it's parser inserted and it does not have an async, okay, there's all kinds of stuff going on here. So if I'm skipping over all of the module stuff, I guess that's probably okay. Fix me, check, classic is module. If has attribute source and has attribute defer and m parser inserted and not has attribute async. Then we are here. But we don't have to implement this right now. So this will be a fix me. Okay. And then if the script type is classic, we have source and it's parser inserted, but we don't have async. So that's going to be us. Has source and m parser inserted and not has attribute async. Then it's the pending parsing blocking script of the document. So when the script is ready, we set the elements ready to be parser executed flag. The parser will handle executing the script. Okay. So how do we do that? When the script is ready. When the script is ready, then ready to be parser executed is true. Okay. The pending parsing blocking script. How do we tell him that? I guess this is where we have to inform the document that he's the pending parsing blocking script. So set pending parsing blocking script. This. It's me, dude. I am the one. Yeah. And when the script is ready, do we always do this? No, we do different things. Okay. On script, when the script is ready. So document should have a pending parsing blocking script. That can only be called by the script element, preferably. Okay, and it will just be a stored in a ref header like that. Yeah, I think that'll be okay. And then in the web forwarding header, or no shit, this is gonna have to be out of line, but script element, pending. All right, so you, my friend, actually have to go in the CPP file. That's okay. It's not bad in the CPP file, it's just different. Wait, this is the wrong place. All right. And then we need to say when the script is ready. Which is a callback that we will invoke somewhere. Wait, where do we put that? Script element. This is just be our little secret. Let's call it M1 since it's a private. Normally I use, we have this style, right, where we say like on foo for public hooks, but since this is a private hook, let's just call it when this M1 the script is ready, just for consistency's sake. And when the script is ready, which might be now. So actually, maybe this should be a function. When the script is ready, to which you pass a lambda of what you want to do. And then it may invoke that lambda synchronously. That might be a bit more elegant, actually. Callback, and then let's see, we'll call that the script ready callback. And then we can have something like set script ready. Script became ready. Okay. We forgot about this helper. Okay, so if mscript ready, we'll call you right away. Otherwise, script ready callback is callback. Yes. Okay, so if it's ready, then we set it up, call it right away, and then we don't set up this thing. Otherwise, we will store it. And here, when we set, we'll call script became ready, which will do the necessary finessing. So script ready callback. We'll assert that we have a callback, I guess, and then we'll invoke it. And then maybe we will drop it so that we don't end up with weird, confusing callback hanging off here. Okay, so that got a bit weird, but I think we're still good. So, what was this? Async, classic. Where are we even? It's a source with no async. So has source does not have async. That's the one we just did. Okay. If it's classic, wait, if the script's type is classic, element has source attribute and the element is parser inserted. So there's so many different states here. I guess we can type them out. So it's classic, source, but no async and not non-blocking. Then I'm just going to assert not reached because I don't know. I feel like we're not going to hit that one. Otherwise, oh wait, hold on. This needs to be else if has attribute src. I don't know where we're going to end up here. XML parser. Otherwise immediately execute the script block. I don't know. Let's see where we end up here. This is getting really confusing. Document needs to see the script element. Parser document not equal. Can't do that apparently. So we'll just say putter. I guess they're weak pointers. You can't compare two weak pointers. Maybe we should let you do that. It's a bit weird that we don't. Will be a good patch for weak putter, but I don't want to edit weak putter right now because it's included everywhere. So let's see. Where did we go? Prepared script. And we try to complete the URL and it crashes. Alright, so wonder why we're crashing. Incomplete URL. Oh, I guess because the URL of this page is empty. When we create the document, let's give him a URL. Let's say there's like file home, or let's say it this way. And then we will pass a URL in. And here we will and then we'll make a URL out of it. Or wait, hold on. We can do this nicely. URL create with file URL or path. All right, good enough. So we actually proceeded. Now, pending parsing block. So let's just go through this and continue with this. So we're gonna need to commit a whole bunch of things here. So let's do that first. And I'm thinking, like, before we try to get the script to execute, let's just make sure we can parse the rest of the document, and then we can focus on getting the script to run. So here in tree node, I'm just adding that call inserted to thing. Inserted into, who calls children changed? Who calls that? Append child calls it. Call inserted into, call do notify. We'll call it notify, and then if notify this, then also that, and then we skip over all the notifications in our case. I think that'll be okay. The web, add a way to opt out of tree node and child notifications. This will be used temporarily by the new HTML parser while we're bringing it up. Nah. Okay, all right. So git add what did we do in document H? Pending parsing blocking script. Let's ignore those. And then we did something in DOM node. We can add that stuff. So it's child text content root and it's connected. But add some helpers to DOM node class. This patch adds the following things needed by the HTML spec. Node root, node is connected, and node text, child text content. Yeah. Then in the forwarding header, what did we add? Script element, exciting commit. Add to the forwarding header. And then the rest is a whole bunch of script gunk. You know what we should do? We should verify that the regular browser still starts. Yes, it does. Cool. All right, so we didn't break it. Good, -a, but whole bunch of work towards spec compliant script loading. Yeah, this is still very unfinished, but there's at least a skeleton code. Okay, and then what's the next thing? Let's just get through some parsing. So we wanted to see what was coming next. It was a h1 start tag in body, right? Yeah. So back to in body. Okay, so in body insertion. And I'm guessing this tag is not special, so it's just gonna be, oh wait, no it is, okay. Right here, a start tag whose name is one of these. So in body, if token is start tag. So let's try this. Names h1, h2, h3, h4, h5, h6. Oh, we forgot to close the h3. Alright, so if it's that and names contains the token tag name, then we are in there. And then what on earth do we do here? If the stack of open elements has a p element in button scope. So we don't have that helper, but we can say if m stack of open elements has in button scope p, then close a p element. Okay, and then if current node is HTML element. Wait, if it's an HTML element with one of these tag names. So if the names contains current node dot tag name, this is a parse error. This is a parse error. Will assert not reached, or will to do. Okay. Otherwise, we should insert an HTML element for the token. Cool. And return. So what is close a p element? Generate implied end tags except for p elements. Oh, so okay, so hold on, let's see what we do with that. Maybe we'll do, wait, is that a common thing? Generate implied end tags except, oh, that's a typical thing. So we could do string exception, and we'll say here file. Wait, hold on. What's that? and current is not the exception. Yeah. So I was thinking, yeah, we'll just have it be default empty here. So you can call it with an exception if you like. And then we needed the close the p element algo was close a p element to generate implied end tags except for p if the current node tag name is not p. This is a parse error to do. And then pop elements from the stack of open elements until a p element has been popped from the stack. Element is let's see, popped element, stack of open elements pop. If popped element tag name is p, then break. Okay, I guess that seems fine, because this guy here will generate implied end tags. This is just about popping things off of the stack. Close a p element. What if, I mean, we're going to assert here if we run out of things to pop, so. But I guess if this means that we already checked here that we do have something, so there should be a p on the stack, so it shouldn't loop forever. Close a p element, right? So, and then we had has in button scope, whatever that is. So we already have has in scope. So we'll add the has in button scope, which is all the element types listed above plus this one. Right, so it's this same algorithm as this one plus an additional also button. So this is a bit of an annoying thing, but maybe we can like, or I don't even know what's a tidy way of doing this. Base list, and then auto list is as space list. And maybe we can make a helper here. So has in scope info const vector fly string. List, and then this stuff will go down here instead, and then we'll just call the upper guy. So has in scope impl tag name, the base list. Okay. Yeah, and then we'll do our button scope thing. with like auto list is as base list and then list append button. So, oops, not the most elegant solution, but it seems fine for now. Right, so now we are in body with a character. So what do we do with that? In body. Oops. Any other character token in body. So we only handled white space so far. So I guess any other character is going to be reconstruct the active formatting elements, insert character, token, code point, frame set OK is false, return. Alright, now we are in body and tag with H1. And end tag, end tag, end tag. Okay, here we are. So let's see. There's an end tag. We can definitely organize this better, but let's write it out this way for now. So what do we do in response to this situation? If the stack of open elements does not have an element in scope whose name is one of these guys, so wait. This is a bit weird, because do they mean that like, oh, an end tag that's one of these, and then you can have something in scope that's one of these, or do they mean that it should be the same exact tag name as the one who's in the scope? They don't say. They don't say that, so I'll assume that they're saying it correctly. But it is a little bit suspicious, right? So maybe we'll do these like, we'll write it out in this ugly way, I think. Gross, 3, 4, 5, and so if we don't have that, then this is a parse error, ignore tokens, to do. Otherwise, generate implied end tags. If the current node is not an HTML element with the same tag name as that of the token, parse error, to do. And then we will pop until we get one of these guys. So I guess we can do that like stack open elements pop, and then if popped element tag name is h1. If this is true, then we break. And then we return. Oh, what did I mess up now? On 489. Oh, I put too many parens, or I messed up the curlies. Where did I do it? Here is it. What's this one match? This one matches that. Okay, in body end tag P. End tag whose tag name is P. So this is this guy right here. If token is end tag and token end tag name is mother frickin' P, then if the stack of open elements has a P in button scope, if it doesn't have a P in button scope, then parser to do. Otherwise, close the P element. All right, in body start tag B. I guess that's here. Oh, and this one goes in the list of active formatting elements. Whew. All right, well, let's just keep going. And token tag name. Let's make a list. So this is the list right here. Okay. Then we should reconstruct, then insert HTML element for the current token, and then push that onto the list of active formatting elements. Okay. Push onto the list. The Noah's Ark clause. Sounds like it might get a little bit strange here, but now I guess we're gonna fail in the reconstruction of the active formatting elements thing. 532. Wait, what the heck? Oh, we're in. Oh. Start tag span. Span. Wait, why is that a parse error? I can't have a span in body. Oh, no, I'm in the wrong place. Hold on. Any other start tag? Hold on, so let's go to in body and then search for any other start tag. Okay, so our fallback here will be if token is start tag, insert an HTML element for the token and return. Okay, now we're at 406. We are trying to reconstruct the active formatting elements. The web, yet more work towards parsing. Welcome HTML. Okay, reconstruct the active formatting elements. So if the last most recently added, so we don't have this marker concept yet, so we can maybe just ignore the marker thing and say if the last is a marker, or if it's an element that is in the stack of open elements. Oh, I think this is gonna be a match right here, so maybe we can get out of it. If tag name stack of open elements wait, is in the stack of open elements, so just contains. I just want to contains. See if it's in there. Yeah. Contains. Contains is fine. Then we can return if that's the case, which would be kick ass. And then yeah, we'll just forward this really contains element. Oops. Oh, it's not that simple. Okay, we have to implement this out of line. But it's no big deal. It's just a little bit of more implementation stuff here because it's a non-null ref putter vector. Element on stack. If element is the same as element on stack, turn true. End tag span. See, it never ends. That was a start tag, so do we have any other end tag? In body. And like any other end tag. Okay, so if token is end tag, node is current node, and then comes a loop. If node is an HTML element with the same tag name as the token, while node generate implied end tags, except for elements with the same tag name as token. And if node is not the current node, that's a parse error, so to do. and then pop all the nodes from the current node up to node, including node, then stop these steps. Wait, hold on. So return to the step labeled loop. Okay, let's write it out this way. If this is true, then we do this and we break. We should pop all the nodes here. So while current node is not node, wait, if node is not the current node, then this is a parse error. Pop all the nodes from the current node up to node, but they are the same. Otherwise, it's a parse error. Oh, I guess it's a parse error, but you still have to do this. So while current node is not node, so while that, stack of open elements pop. Pop once more to pop node off. Otherwise, if it's in the special category, then we have to do some special thing. Oh, okay. Then it's a parse error. Wait, how do we check that? We just check the tag name? Oh, this is too tedious. I'm not going to do those. I'll do this some other time. I'm getting too tired for this kind of crap. Special nodes. Fixed me, blah, blah, blah. Set node to the previous entry in the stack of open elements. Wait a minute. We're supposed to iterate backwards through the stack of open elements. Oh, hold on. M stack of open elements. I'm not even sure what's going on here. This is the part where we step out of the loop. Okay. So what is going on here? For this, we'll need to expose we'll expose this vector here so we can iterate over it backwards. Okay, and then size ti is on. Oh no, wait, hold on, let's do this backwards. So I is m stack of open elements, size -1. So backwards iteration, everybody's favorite direction. Node is node. yeah, so here we're just, they have this convoluted way of writing out what's essentially simple code. It's just so weird when you translate from this confusing English into this like kind of obvious C or C++. Okay, and then loop around. That seems fine. And then we'll return at the end of that. So in body, and we get a frickin' new line, and we're dead. 409. Oh, we're trying to reconstruct the active formatting elements. Dang it. All right. Let entry be the last, most recently added element. Element entry is the last element added. Okay. If there are no entries before entry, so if m list of active things, size is 1, go to create, I don't know. So this here is rewind, and then let entry be the entry 1 earlier than entry in the list of active. Oh, I see what we're doing here. I see what we're doing here. Backwards iteration again, huh? Well, so go to the step labeled rewind. Maybe we shouldn't get carried away with the iteration thing, but we'll say that list of active formatting elements size -1. All right. And then entry is essentially at index, sure. And then if it's neither a marker nor an element that is also in the stack, what's a marker? It's used for these goofy elements. Yeah, so we're not going to care about those right now. So if elements is not in the stack, wait. No entries before entry, then jump to create. Yes. Otherwise, entry is the one earlier, so entry minus index. Entry is list of active formatting elements at index. If m stack of open elements contains, so it doesn't contain entry, go to rewind, advance. Entry is one later. Oh, holy moly. Okay. And then we go to create. Insert an HTML element for the token for which the element entry was created to obtain a new element. Ooh. I don't have that. So I have to hold on to the tokens for these things. Interesting. Insert. Okay, so what if we get a little bit lazy here? Hold on to the real token. So we'll just make a fake token here. Fake token is type start tag fake token tag name append. This is so stupid, but entry tag name, and then we use our fake token. Okay, and then replace the entry for entry in the list with an entry for new element. So list of active formatting elements add index is going to be the new element. Haha. No viable overloaded. Oh shit. Wait, can I get to the putter at? Yeah. So there's a way to do this. Putter at. If you want to overwrite. At least I thought I could do that. I can't do that. Can I do? What is this thing? New element is what exactly? Ref putter to element. Oh. Gotta do it that way. I'm not sure this one can fail actually. Okay. If the entry for new element in the list of active formatting elements is not the last entry in the list, return to the step label advanced. So if index is not stack of open list of active formatting elements, size -1, size t, then, my friend, go to advance. Otherwise, we made it. We made it. My God. You could probably write this in a different way, but I'm deciding to just write it the way that they spell it. And that was it. We actually parsed. That's so cool. And this is our DOM. That is very, very cool. I wonder if it would load if we, did we say we made it a bunch of times somewhere? We made it. Yes, we made it. Okay. This algorithm here is clearly hilarious, but it is very reasonably faithful, although we're not doing the marker thing. Fix me, this needs to care about markers. Okay, so what? Finally, parse enough that we can actually handle welcome HTML. We made it at last. What a long journey this was. Man, I'm gonna change one thing here. I'm gonna put an exclamation point. Okay, so we have parsed the thing. Let's put it up in the browser. So where we currently parse HTML document in the HTML view class, Where are we parsing it? Create document from MIME type. What are you whining about? Unused function. Are we not calling this? We are calling this. Why do you think it's unused? I don't know what's going on with these warnings sometimes. So here, we're going to call our new big boy parser here just to test it out. We're not going to make it permanent. Parser, HTML document parser. Right, so new parser. Data. And then new parser run URL. And finally, I guess we'll return the new parser document. Will this work? I wonder. Well, we got something. What are we looking at here? Inspect the DOM tree. Okay, so what went wrong here exactly? Here's our body tag, sure. We have style, sure. We didn't run the welcome script, but I would expect it to run anyway. I mean, to work. Welcome. So what is actually supposed to happen here if we compare? It's not immediately obvious to me what's wrong, so let's see. The head has title. Title is good. Welcome. Sure. We have some comment. Sure, right here. We have our CSS. I don't know if it cared about CSS at all. Possibly it didn't. Welcome to the Serenity browser. It seems like he didn't care about the CSS actually. So the CSS is in line here. Oh, wait. I think we're not actually telling it to do anything with CSS because we turned off those notifications. So we're not going to parse the CSS because the parsing the CSS is happening here, and children changed. So what if we just hack this? Because right now I'm a bit too tired. I'm not going to be able to do everything I wanted to today, but just want to see it working. So if we say notify, say we still tell him children changed, right? Or what if we neutralize script element so he doesn't do anything and insert it into, and children changed also, and then document parser wherever we did the script. Oh, it's right here. So if we allow those callbacks to fire, then it still doesn't fire. Okay, well, we don't have any style sheets. What does our DOM look like? I mean, this is the CSS, so why don't we get the stuff? Style. Oh, wait, hold on. We're not going to call children changed at the good time. Right. Yeah. So the problem is that we're not notifying the style element that it was inserted into the document. We should really be getting here. Why aren't we here? hello. Yeah, we did get it. But we got, see, we're getting it and then we start actually parsing the CSS. So getting it too soon, that's the problem. Children changed. Oh, because we're inserting a text child and then we keep appending to that text child. So I think the horrifying thing that we can do here is when we do insert character, when we append to the existing text node, we can say existing text node parent children changed. This will give you many opportunities to parse CSS and may very well murder our CSS parser. I feel like he got mad at me. Yeah. Why did he get so mad at me? I guess probably it hangs the CSS parser completely. Now I have two of them for some reason because I'm stupid. They're gonna be hung in the CSS parser most likely. Can I click on one, please? Yeah, look at that. That's stupid. All right. What's a stupid hack we can do here? We make a timer. Core timer construct. Call me back in 1 second. And don't worry about it. Just do this little thing for me, please. Hey. And we need core timer. I just want to see it working. Oh, I can't do that. Okay. Hey. So we'll capture that by value, and then we'll call children changed after 1 second. We should do 5 seconds since we have some time to spare. And it's not more const. Ugh, get over yourself. I mean, I wanted this to come up. Oh, but the timer goes out of scope. Oh shit, we have to leak it. There we go. Because timer got out of scope and it got destroyed because of that. So we have to leak it so that it stays alive. Okay, so we parsed. Come on, trigger the CSS. No? Dang it. Timer interval. Wait. Oh, no, we have to call it on the parent. Okay. Oh my god, this is horrendous. Alright, come on now. I want to see it change. Why doesn't it work? Does this even take milliseconds interval? Oh, it was there. It just needed to trigger a repaint. Okay, so it actually did. It actually did parse the CSS finally. Okay, so yeah, I think this is as far as we're gonna get today, but I'm really happy with the progress. So thank you very much for checking this out. I hope that you found something interesting here. I know this was a long and arduous video, but I feel like we really got some stuff done. So that's really cool. Thanks for hanging out, and I'll see you next time. Bye.